Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Thanks for coming to the second session of our Dynamic Languages for Scientific Computing area. And for this part, let me tell you a little bit how it's going to go so you can kind of figure out how you want to split your time here. So the first part is going to be an overview of this show language, talking about what it is, what its capabilities are, kind of an introduction and overview and so forth. And then the second part is going to actually be more of a workshop. So if you want to kind of like see how to actually build your own things in show, like write a little bit of code, or maybe I'll write some code and you guys can watch and heckle me, or whatever we decide makes the most sense. So to go ahead and get started, so this is show. And who is show? Well, it's been 4 of us who've been really developing this for the last 5 years or so. Aaron Renshaw, John Platt, Chuck, and myself. So everyone sees who's involved there. And a lot of help from people in developer division here at Microsoft. A lot of really, and you'll see that when we talk about the architecture of show and how it works. So before we get started, I'd like to do a little bit of a poll. How many people here have used MATLAB? Okay, pretty much everyone. How many people have used Python? Almost everyone. Okay. How many people have used R? Okay, still good sampling. And how many people have wanted to or had to connect your script code to some kind of compiled code or library? Or maybe you've wanted, oh, okay, well, good. No wonder you're here at this talk then, because, okay, this is, then you're a very relevant audience. So that's often the case, as you probably know. Like, you reach some limits within your environments, and then you have to do some work. And Jan talked about some of the challenges that come about when you want to do that, and I think show provides some nice solutions to that. So what is show? Fundamentally, show is a lot like any of these other environments. You have a interactive command prompt where you can have these mathematical types, and you can have plots, and you can type things and look at them interactively and so forth. But what makes show different, and we'll talk in greater detail about this, is that typically when you're doing scientific computing, you don't do it in a vacuum. I mean, it's not that you just have a text file with your data and you can just load it up and really just kind of get your answers. Especially with the kind of people who've been able to leverage show the most, they have data coming from SQL or maybe from web pages, from web services, maybe from files, some log files, documents, or from the cloud. All kinds of different places that they're getting data. And then they want to do all these things with it. They want to be able to do the kind of math and linear algebra and the plotting and visualization that they're used to, but also do things like interact with code, which lets them do some of this stuff. And sometimes, actually this is another question maybe for the audience. How many of you have found yourself in a situation where at the end of your prototyping within a scripting environment, you want to make some kind of a GUI or program or prototype that somebody other than the experimenters will use? So, okay, reasonable sampling of that too. So that's another place where people are kind of like, okay, well, now I'm done. I don't want to rewrite this whole thing in C++. What do I do? So the goal, as I always like to say, is that we want to do all this stuff so we get to insight in the end. And as Jan was saying, especially from somebody coming from the scientific point of view, developer productivity is key. You want to be able to get to that insight as quickly as possible with as little work and as little time spent doing the mechanics of programming. So before we go too much further, I wanted to just do a very brief demo of what show looks like. What's that line? Well, I'll keep that in there. Okay. So one of the most useful features of show is that here it is. Let's make a nice big font that's bold. Okay. That's better. Can you see that reasonably? Okay. So, it has the kind of things that you'd expect where I can make a nice array like that. I can plot some slice of that. For instance, make a little window. I think the things that start making Show really interesting is that also because it has this deep tie-in with the underlying .NET libraries, doing something like making a form, for instance, is that simple. And if I do this, well, it's hidden back here, but I have a little form. I can now I've made a little form with a crappy little button. but the point is that it's very easy to do this sort of thing, as well as a whole host of other capabilities, which I'll talk about going forward. So let's go through some of the capabilities that Show has kind of built in under the hood. So we definitely have the math and the numeric libraries that you'd expect, both dense and sparse, lots of different types that you might want to use. We have the math-like syntax, operations and submatrices, and our underlying math is actually speeded up by Intel's math kernel libraries, which makes them very fast and for most kinds of things. And we have all the decompositions you'd expect, SVD, LU, Cholesky, those kinds of things. We have a whole range of different visualizations, from charts and histograms to being able to actually look at numeric data as in false color kinds of diagrams. And again, as Jan was pointing out with R, or you've seen with MATLAB, or with other kinds of libraries, these are kind of in the common class sorts of things that you'll find in most of these environments. We have a bunch of nice things in our console. And this becomes particularly important in terms of the .NET tie-in, where if you have a partial type name that you've typed in, you can actually get tab completion for the large number of things. And if you're using a whole set of complex .NET libraries and types, it's nice to be able to get all this information about what's actually going on in those and what things you can use. We also have a facility called Doc, which makes use of introspection, as Jan was talking about, in this case to kind of help you navigate what's going on inside a particular library. So basically, at runtime, you can inspect a type. And so in this case, I'm doing it on a particular class, but I could do it on a particular instance of a class as well. And then it basically reflects on that class and that type, and it shows you all the values and variables and information in this nice searchable window that you can go and see in real time kind of what's going on with your class or type. So the fundamental question, I think, comes down to this. It's like, okay, well, those are kinds of things that you can do in most of these other interactive languages and environments. Fundamentally, how is this different from MATLAB or anything else? Like, what's special about this, and what makes it worth looking at potentially? And I think that the real difference comes in here, where if you look at your standard environment, and that's a picture of MATLAB, but most environments are kind of like that. You get the math and you get the visualization, and that's great. And that's powerful that you get a set of libraries, and that's really useful. But on the other hand, shouldn't really even say Microsoft, but there's a whole set of libraries that are out there that are, you could say on the one hand, are kind of developed by, say, professional programmers. As scientists, generally, our core competency is not programming. Like, we're kind of there to get our programs done and to be able to investigate the questions we want. The programming language is kind of not so important. But there are people who are in the business of making great libraries to do all kinds of stuff, to build enterprise software, to access resources on the cloud or things like that. And all of that stuff is often built, in these, professional environments, so to speak. And in this case, like, there's all these .NET libraries that do these fantastic things. And what we find is that a lot of times, and this is what I was asking about in the poll earlier, if you're somebody who's kind of on the algorithmic or scientific side, you'll often have this environment. It'll be accessible to you, and that's great. But you find yourself at certain points in the project where you wish that you were able to do some of the stuff on the right as well. And similarly, sometimes you'll have people on the other side come in this other direction where they're like, okay, well, we have this, these fantastic libraries for doing this stuff, but now we'd like to wrap up these nice new experiences very quickly and to make rapid prototypes. How can we do that? We'd really love to have something that was much more playful in this kind of environment. And so Show tries to achieve this, and this is fundamentally what happens. And what you'll see in the end is that Show is a very thin layer on top of a lot of work that other people have done. So there's this whole set of .NET libraries, everything that's in the whole system of .NET, that whole infrastructure. And on top of that, Developer Division originally created this thing called IronPython. And what IronPython is it's a full Python. It satisfies the Python spec, but it runs on the CLR. It runs on the CLR, and just as with Jython, which runs on the JVM, basically that means that not only is it a Python that's written in .NET, but that it speaks natively to everything in .NET. So you can bring in .NET objects, and you can talk to them. You can script them from inside IronPython as a scripting language. But in order to, so what we've done, so up to here, this is kind of like, what we kind of started off with, and the rest is what we've added on top of that with Show. So one of the things we wanted to do was, really make a console that kind of made it nice for people who are doing scientific prototyping. And so we did a bunch of work in the console to make that kind of nice. And then at the .NET layer, we wanted to extend what was there already in .NET and IronPython in terms of having a solid numerics library for doing linear algebra and doing optimization, those kinds of things, and then also having plotting, charts, and other kinds of visualization. Because as wonderful as .NET and IronPython were, they didn't really have those capabilities built into them. And so we've kind of added things there to kind of make it more complete. The nice thing about those things being at that part of the architecture instead of on top of IronPython is that you don't have to use this stuff from Python. If you want to use it from C#, you want to use it from other languages, that is completely fine from any .NET language. And then finally, this thing in the last corner is our package mechanism, and the packages tend to be some combination of things that are built on the .NET Core, and some of it's built in IronPython as well. So it's kind of a mixture of these two. But a lot of the main core packages like optimization are really built right on top of .NET. And even though I said these boxes come from Show, we still beg, steal, and borrow as much as we possibly can from other things that are going on in Microsoft. Like there's a ton of groups that are doing things like there's the whole Microsoft Solver Foundation, and for our optimization library, we have a few things that we added, but a lot of it's just taking that Solver Foundation and making it really accessible to programmers who are writing in this way. So as I was saying before, Show is .NET all the way down. So this means you can have arbitrary .NET objects, and you can subclass them and override behaviors, and you can use all the enumerators. And one of that last point is actually really important, which is there's no wrapping or decoration needed. As Jan was talking about when he mentioned some of the work earlier, where he talked about having 1.7 million lines of generated wrapper code. That ends up being a big liability. And I've worked with languages before where I've had to use Swig and create those wrapper languages, those wrapper libraries, not only because it's just a lot of code to keep around, but then debugging kind of becomes a nightmare because now you're stepping through chunks of generated code that you didn't really write, you don't really know, and things interact in weird ways. It can be quite problematic. And the nice thing here is there's no such wrapping. As long as your library is in .NET, you can just talk to it directly and use it directly. So this example, which I actually showed you already, is you can just create a form, and with 3 lines of code, you've got a form running. I did nothing special to make that work. So an example of using a .NET library from Show, it's as simple as basically saying that, like, well, okay, we have this command that's called load that basically lets you point to some DLL, bring it into your namespace. And then you just do a little bit of setup. You say that, well, I want to import these symbols. As if you've seen Python syntax before, you know what this is doing. It's just kind of bringing those symbols into the main namespace. And then I instantiate a speech recognition engine, and I set its grammar, and I say recognize. And that's it. Like, you could actually just take that chunk of code. Somebody else, on some other computer somewhere else could just type in those lines. There's no project. There's no Visual Studio project backing it. There's no bunch of DLLs you have to pass around. It's just that code, and you have something where you can speak into the computer, and it will try to recognize what you said. It might not get it right, but that's all it actually takes in order to get speech recognition up and going. So, and this is the kind of thing where we like talking about the typing to wow ratio, or the wow to typing ratio. Because you want the wow to typing ratio to be high. You want it to be the case that, like, well, I've made this complex thing, and now I'd love to add a little bit of speech recognition, or I'd love to be able to, to connect to the cluster, or be able to talk to a web service, or have a connect input, or something like that. we want the effort of being able to bring in that other stuff, those outward-facing connections, to be as easy as possible. Here's another example. This is a story I ran into that I like to tell, where essentially, so I was in the situation where I was doing a data mining project. We're trying to do some data clustering, interactive clustering work. And we had a whole bunch of papers like this, and we needed to extract the text from the papers to do the analysis on them. And I was like, well, I don't know, how do I get the text out of the PDFs? And I looked around. There were some shareware programs and things like that. And then I remember that there's something in the Windows subsystem for the search index that actually takes things like PDFs or PowerPoints or whatever and pulls the text out of them somehow. And I was like, well, how does that work? So I asked one of my colleagues, and she said, oh, I have this C# file called ifilter reader. Why don't you just use that has the code in there? So in this case, I didn't actually even look inside the C# file. We have a facility in Show so that you don't actually have to have a Visual Studio project. You can just have a raw C# file, and it'll just compile it in the background and pull it in. So I just took our C# file, I loaded it, and then I I tabbed around a bit to find what the namespaces were, and I pulled in this ifilter namespace, and then there was only one class in there, ifilter.default parser, and it had this method called extract. So I just tried running that in a PDF file and printing what I got back, and that was it. So it was like a very, very low effort way for me to bring in, to not only leverage this library that somebody else had written to do the ifiltering stuff, but then this piece of code my colleague had written, just being able to pull that in and use it with a minimum of hassle and a minimum of extra effort. Here's another example of the kind of thing that is nice to be able to do. Using web services is also quite easy. There's a tool. This is part of. There's some mechanics here, but so there's tools in the .NET stack called WSDL, which basically, or WSDL, which basically lets you point at a web service, and then given that web service will create a C# wrapper, or actually a wrapper in other languages as well if you want, from that web service. And then once you create that C# file, it's the same workflow as before, where now I can load in that C# file, and then I can import in the proper namespaces, and then I can use this just like any other class. And in this case, I'm using the web search API from Bing. And I can just, I can execute a search, and then I can step through the web results, and I can kind of, go through these and print these and all this sort of thing. And again, the high-level point is that the level of effort that it took to get from existing tools right into something that I can use interactively and play with the types interactively is very low. Very little extra setup from what you would ordinarily have to do. It's also quite easy to build GUIs, of various kinds. You can use GUIs that you make in Studio. You can just write them, code them up by hand. I've built a number of things and prototypes that way for this, as well as other colleagues around Microsoft and beyond. There's a range of packages of various kinds. There's a bunch that we ship right inside the box, including stats, optimization, signal processing, connections to database, and then we have a few that are online and publicly accessible. For cluster computing and cloud computing. I'll talk a little bit about those more in a second. Shortly, we're going to release some stuff around. The Connect is more or less released. It's kind of in a blog entry. It's very short, so you can just kind of load in the code. But we'll probably release it more formally. And some stuff for doing dynamic web apps. And there's some other libraries that are also under development. And on the one hand, it's hard to compete with some degree, as Jan was talking about. R has these, what is it, 14,000 packages now. 4,000 packages. So we don't have 4,000. We have more like 15. But a lot of the times, it depends on the sort of thing you want to do. We find that a lot of the things that are core, and this may be more true of, R is more statistically specific, but if you look at Python and you look at a lot of the packages that are out there for Python, a lot of the times those things are kind of meant as specialty packages to do something like talking to web services. And in those cases, a lot of that stuff's already built into .NET, or there are existing .NET libraries you can just use. So it's not really a one-to-one comparison there. There's just a lot of great facilities you can just absorb other people's libraries for already in the .NET case. Here's a quick example of how the cloud instance works. And I always like to say that why would I just waste my own computer's time when I could waste thousands of computers' times at once? But these days I find that more and more, maybe especially in machine learning, but I expect in a lot of areas that it's very easy to create a job that you have to wait for to run overnight, or maybe it takes a week, or you distribute it in 2 or 3 computers, and you end up wasting a lot of time. And if you knew that you could get your answer back to your big experiment, your big Monte Carlo run in an hour instead of over the course of a week or 2 weeks, that would actually let you try more things, ask more questions in your science. And so we made a workflow which is quite simple. And essentially the idea is that here's a case where I created this procedure called cluster proc, and I just call it locally in my machine there in the first line, where I'm just saying basis boost.clusterproc, and I'm calling it with some set of parameters, and then some particular value for a different parameter. And then I'm giving it a data directory. And then in the second line here, I'm just setting up a cluster with this call that we have that just kind of points at a particular HPC cluster. And then all I have to do to run on cluster, if you compare this third line with the first one, all I'm doing is I'm saying cluster run of that proc instead of just running that procedure directly. And now instead of a single value for the argument, I'm giving it a list of possible values. And once again, I'm pointing to the same data directory. And what it's doing under the hood, if you're running either on HPC or on Azure, is it's copying the data directory over, it's finding the dependencies and moving those over as well, and then it's turning that one statement with all these different parameter values into a whole bunch of different, into a job with a whole bunch of different subjobs that has these individual values for each one, and then at the end it'll collate all those together in terms of with this get results command. So doing embarrassingly parallel or MapReduce kind of workflows are very easy in this kind of paradigm. Another thing that we've done recently, which we're going to be releasing soon, is this show CGI package. And the idea here is that we were just talking about this at lunch. I mean, making dynamic web apps can be, unfortunately, very complex, and it's often a whole different type of programming than just doing client-side apps or client-side procedures. And these days, in certain fields, so bioinformatics is a great example where journals will want you not just to publish your results, they'll actually want you to put up a web service that lets other people go and upload their data and actually try it against your algorithm. And it seems like it's becoming more and more important or even if you just want to create a simple demo, if you have your algorithm, you want to be able to put it up there. Being able to make a simple dynamic web app that lets people kind of come in, try some stuff, maybe play with some parameters, throw some of their own data onto your system, and try running your code is important. And we have a package that makes this quite easy. And within 50 to 100 lines of code, you can quickly make relatively complex web flows. You can even have logins, and cookies and all of this kind of thing. So we're trying to stick with the philosophy of keeping it easy, letting you focus on the science, and having fairly simple efforts. And if people are interested, I can show what some of that code looks like later. Another package we did recently, you've probably heard about the Kinect SDK that came out of Microsoft Research in collaboration with the product group. And one of the things that we were thinking here was that, here's a great example of something which has a .NET API, which should be a very small amount of work to be able to get into show. And the idea there was that, hey, on the one hand, there's going to be people like game developers who are happy with writing huge amounts of code and using complex libraries and doing whatever it takes to make stuff work. And then there's going to be people who are like, well, I kind of want to work on gate tracking, or I want to do some Kalman filtering, or I want to see how I can recognize gestures and work on a gesture recognition algorithm. How can we make it easy for scientists like that to just be able to pull in the information that's coming from Kinect and use it easily within their code? And in this case, I guess unlike some of the environments that Jan was talking about, show is multi-threaded, so you can actually have a GUI thread and a background thread that's gathering this information. So you can actually have real-time visualizations like these. Actually, these may actually run. Let's see. I know what our network situation is. Oh, there we go. So here's something that was I think it was, oh gosh, how much code was this? I think it was 70 lines of code. And it's just actually using standard show plots to plot this guy. And the idea is that when the hands get close enough together, it creates this 3D bar. And if the hands come apart, then the bar goes away. And then it's just plotting in real time from what's coming from the Kinect, and it's 20, 25 frames a second. And again, with very little effort. That's the key part. Of course, you could do this in any language. The question is, how long does it take you to get from the idea to something that actually works and lets you kind of get to the next step. Another really nice aspect that's kind of coming up, this is in release candidate right now. It'll actually be, but it's public. I mean, people know about this already. It's on CodePlex. It's actually an open source project from Developer Division called Python Tools for Visual Studio. And for those people that really like to work in an IDE, this is a fantastic set of extensions for. In fact, it turns out this is not just for Show or for IronPython. This is for any Python you might want to use. It gives you the whole Visual Studio-like setup. You get completions for all the things that you might be typing in. You also get the abilities to, do things like find all the references for a particular procedure, and if you're working on relatively complex projects in Python that have a number of files, this can be really, really valuable in helping you navigate your code and get code written. And we'll see this later if people are interested in the workshop later. I'll show examples of what it's like to use this tool. It also has its own console, and we're working with those guys to make that full-fledged in the way that the Show console is. So that's a nice experience as well. I think I'll skip this demo for now because we'll actually end up seeing it more in the workshop part. So another question people often have is like, okay, well, now I'm done with a particular stage of my project where I've done all the prototyping and I kind of understand, what I want to do, what my algorithm should do. Now I want to actually do the same thing from a compiled program. I have a product group that wants to build something and they want to make use of this algorithm, so they want to use this directly from the C# side. So as I was showing you in the architecture diagram, all of our code is for the numeric stuff, for the plotting stuff, is there right on top of the .NET layer. So you can access it directly from any .NET language. And essentially all you have to do is do a usual kind of a few includes of the appropriate libraries. There's one piece of setup that helps it find where a particular set of libraries are. And then after that, you can just create arrays. You can do array math in syntax that we try to keep as math-like as possible, though it's hard to do across lots of languages. And you can make figures and some of the same kind of simple workflows where you don't have to do a crazy amount of setup. If you just have a vector and you want to make a plot, you can literally just call the plot command from inside this environment, from inside C# as well. So you get a lot of flexibility in terms of being able to do the same kinds of thing from C# as you can from Python. Now there's a whole other type of story which people ask about also, which is that once you've written something in Python, can you call that Python directly from C# or from some other .NET language? And for that case, we also have what we call embedded show, which is a mechanism in which you can actually embed a show interpreter inside your C# program, and you can actually create a separate console for that interpreter, so you kind of have the inside-out approach. And so this harkens back to kind of some of the Lua stuff that you were talking about. You can use it in the same sort of way, where you have access to the C# internals of your program from this interpreter prompt that you're running embedded inside your program. That can be quite nice for certain kinds of workflows. So to close up and to see how to get started, but I guess we'll get more into this in the second session. All of Show is public now. If you go to research.microsoft.com/show, you'll see not only the download site and things like that, but you'll also see links to our blog and our forum and all kinds of means to contact us externally in order to talk about what's next. We have a book, the Book of Show, as we like to call it, in PDF and HTML, which is a good kind of introduction to the libraries. It's more of a kind of casual intro and walkthrough than it is like an absolute reference book. And for the reference side, we do have an API reference, which has MSDN style type documentation for everything from C#, but you can also use that from the Python or whatever language you want to use. So I think that's it for the, oh, sorry, it's not it. There's one last slide. So the take-home messages of what Show's about. So fundamentally, Show has linear algebra visualization and packages, and they're available to you both from the REPL and from C#, whichever style you want to work in. And I think the most important part about Show, the place where it has the most leverage, is that it lets you move smoothly between your script code and your compiled code. So if you're in a place where that's an important part of what you're doing, that you need to have both compiled components, and you're working with existing code, and you want to be able to do script and do scripting and algorithmic work that's in the script world, this is a potentially very powerful tool for you. And of course, you can use all these existing .NET libraries too. And the last thing I guess I'd say about all of this is one caveat. And I think that I just want to make this clear, especially in light of what Jan's talk was, where that there's, as you've seen, there are a ton of scripting languages available out there for you. And the choice of what the best one is for you is a very situation-dependent choice. I don't think there's any one right answer for everyone. It would be silly of me to say that you should always use show. It would be silly of someone to say you should always use R. But it really depends on the kind of thing you're working on. If you're a statistics researcher and you're working on top of developing new algorithms that are based on the algorithms of 10 other people who are publishing in the stats community, R is probably the right choice because all of those things are probably already implemented as R packages. But if you're somebody who's kind of in this in-between world of like, okay, well, I have, I'm building these dynamic applications and doing prototyping, but I also want to kind of leverage a lot of compiled code, and there's interesting libraries and maybe mechanisms that exist in the .NET stack or other people's .NET libraries, then this is a environment that might actually be very good for that type of development. So that's it for part one, and I'm happy to take questions at this point. Okay.
So I've been working on a system that's similar to this, and maybe there's some places that we could collaborate. The variation, though, that I've been working on is that it's you can switch languages between, say, IronPython, IronRuby, or another .NET language, and it also runs on Linux and Mac.
Nice.
So it only uses mono-appropriate DLLs.
I see.
But as long as you can do that, you can just drop the DLL in, and it works just like Shell.
I see.
But maybe things like package management, we could do similar work together.
That would be really interesting to see. Yeah, please come chat with me afterwards. It would be great to hear more about that.
So how much is it to package up a .NET library into the Shell package?
What's the effort?
Packages versus .NET libraries?
Yeah, so generally the effort is pretty minimal. So there's cases, and I'll show you some during the workshop, where you can have an existing library. So the speech recognition one is a good example, where it's kind of like, we could make a speech recognition example, but a speech recognition package, but it would be kind of silly because it would just be like, well, here's a Python file with 3 lines in it, and you could just type those in yourself or put them into your own code. So it's the kind of thing that would make more sense as a blog entry probably. So fundamentally, there's very little additional work that goes on. The reason that most of the packages exist is that sometimes the .NET libraries were designed with a statically compiled language in mind. And that means that they have very rich and very deep APIs, which are great if you're kind of writing some very well spec'd out program, but they're overwhelming if you're trying to kind of get through them as an interactive programmer. You're like, I just want to call a function called optimize. I don't want to think about the 850 different possible signatures that function might have. So a lot of the times the things we do, so plot, our whole plotting library is a great example of that. It's actually built on what's called Dundas charting. It's something that's part of SQL reporting services. And we just make this layer that makes it to the point where you can type plot X, Y, and it just creates a plot for you, as opposed to having to set all of this stuff up. So it's often a simplifying layer. Okay. Well, we can move on to part 2. I guess we're pretty much at the halfway point. Okay. Well, why don't we go ahead and get started with the second part. So the idea is, so I called this the show workshop, and nominally we can see what makes the most sense. So there are links to actually get the tools I'm going to talk about, and so there's 2 possible options. And the first one I call I get to heckle you, and the second one you get to heckle me. So we can decide which one makes the most sense. And maybe we should step through at least one together. But anyway, so I have a bunch of little exercises here, and you can download these afterwards also if you'd like to kind of just try them out as interesting programming exercises. But I'll step through what they are first, and we can kind of choose as a group maybe one to start stepping through together, And if people want to kind of go off and work on some on their own, that's fine too. So let's kind of go through the exercises. So the first one's very basic. It's just about plotting data. If we take like a file that's got country populations and names and areas, the goal is to just plot the areas versus populations, add some of the names, as labels for those points, and then fit a line to that data and plot it. So that kind of goes through some interesting Python stuff and kind of gets you into the flow of things. Number two is text analysis, where the idea is doing frequency analysis of text files. So here we have a small corpus of text files. So in this case, paper abstracts. You can just load these all in, and then you can compute the frequency of all words and have a bar chart of finding the n most frequent words. Number three is making a simple labeling tool GUI, where the idea is that you have a file of sentences that you want to maybe label for sentiment, and you want to be able to make a little GUI which kind of loads those sentences in, shows them one at a time, and then you hit a button for if it's positive or negative or something like that, and then maybe saves those labels off to a file. And then the fourth one is kind of fun. It's a voice calculator, basically doing simple math with voice I/O. So it'll use speech recognition and speech synthesis to let you kind of speak simple mathematical expressions and then be able to produce the output. So what do people think? Is there one in particular that people are excited about? Should we just vote? Maybe. Okay, how many people vote for number one? Oh, it's not very popular at all. How about number two? Got 1, 2 votes. Okay. Number three, the labeling tool. Second to people. Okay. I'm guessing there's more people interested in number 4. Somewhat, okay. Or is there other kinds of things that people would rather explore that would be interesting too? You can feel free to, this is meant to be interactive, you can feel free to shout things out that you're interested in seeing or trying or something like that.
Sumit, can you bring the first page back up, the URL?
Oh yeah, sorry. Has everyone got the URL? Okay. Well, okay. So there's no interest in number 1. Someone's number 2. It seemed like there was the most interest in number 3 and number 4. Well, we can maybe we can see a little bit of we can maybe start at the back and then we'll kind of see a little bit of how this works. I think this one's kind of a nice example. I'm going to sit down here so I can type more easily. It's kind of a nice example in that it kind of shows a little bit about, how to bring in these extra .NET types and whatnot. So let me pop out of here. And okay. So this is the Python tools for Visual Studio with a gigantic, easy reading for the blind sort of font. But hopefully you guys can see what I'm actually doing here. So actually I have that particular one pulled up. So let me tell you a little bit about what's going on in this file. So IronPython has this directive called add reference, which lets you basically say that, hey, I've got this particular library that I want to use. And so for a lot of internal libraries like speech, there's some additional DLLs that need to be loaded by the subsystem, and so you can point it to it with that. And then I'm importing the speech synthesizer and the speech recognition classes. And then I have this very simple little procedure to start with, which basically, if you run voice demo, creates a speech recognition engine, opens the default audio device, and it loads the default grammar, and it starts up a speech synthesizer, and basically it adds the event on speech recognized to the speech being recognized. And so what's happening here is that in that function, in this case, it'll just say you said whatever it is that you said. It's not particularly exciting. So let's run this and see what it does. This is the test.
You said thighs is the test.
Dice is the test, apparently. So that's the basic loop that we've got right here. And currently, it's not very much of a calculator because it just takes what I said and sends it back. So any suggestions for how we can make this more calculator-like? Okay, hold on. Here's a hint. How about we try filtering for, let's try to make something that maybe adds two numbers, right? So I can have a filter for the function here, and I can say that, like, if it starts with add, then maybe I'll do something, and maybe I'll only print the things after the result of that. So I'll just make my life easier by saying. And so you'll notice well, you might not be able to see it back there, but oh yeah, I guess you can. But Visual Studio is actually smart and knows about the different functions that this thing has, because it's been able to actually infer that this is a string that I'm talking about. So I'm going to say if it starts with add, then I can say speak, you are trying to add, and then I can print the whole result, but that result will start with add, so it won't be kind of quite what I want. So I can create another thing, which is expression, which is going to be everything after the first word that's in that string. And so I can create this. Well, let me hold off on that first. Oops, sorry. Sure. I think one of the benefits of being able to work in a dynamic environment, of course, is that you can keep iterating and trying without having to necessarily worrying about getting everything right on the first try, especially when you're typing in front of an audience. So let's reload it and add 47 and 52. Okay, well, that didn't recognize that. Add 47 and 52. Okay, well, maybe we should still print what it actually sees, since clearly it's not getting what we think it is. Add 47 and 52. So it's getting added. Maybe we should use a different phrase that will be recognized more easily. Sum 47 and 52. Riesling. That's not good. Well,
it's uppercase, and you were just checking for lowercase.
It's true. I can do the two lower. I guess added would be okay if I do check for lowercase. So that's a good point. I like that suggestion. So let's stick with add. So let's do text.to lower, and then have that start with add. So we'll see if that fixes things for us. It's a good suggestion. add 47 and 52. I'm not having a good speech day. Okay, let's try with the mic. Add 47 and 52.
You are trying to add added 47 answer easier.
That's not going to work very well. Yeah, so I think my guess is that the voice calculator will probably not work very well in a large lecture room environment. I'm trying to try subtraction. Okay, let's see what subtraction does for us. Subtract 34 and 52. See, the great part about using other people's libraries is you can blame someone else when things don't work. So in this case, I think I'm going to say that this is not going to work in this room and move on. Generally, most of the, to be fair to that team, and I'm sure they'd yell at me if they saw me doing this, because most of their models are basically designed for close talking microphones with a headset. So it's a little bit. What? That's right. Yeah. Every other time it's worked perfectly, just as Ed said. That's right. But hopefully, I think that the higher level point I was trying to make with this example is that trying to make something that has both speech recognition and synthesis, albeit poorly, is pretty easy to wrap up and put together. Okay, I'm going to move on to the third example, which is around looking at, maybe the third example was the GUI example, actually. So, so what does it take to make a simple GUI and have it actually do something? As you saw earlier, you have direct access to all of the objects that are in the .NET hierarchy. And fortunately, forms are fairly simple to use just programmatically. You don't need to use all the special wizards and stuff. You can just kind of quickly create your elements and stick them together and make something if you're making a basic UI. So in this case, I've pre-made this little class that I'm calling labeler, and in this case, it just has a basic form, and it's got some parameters, and then I've added this prompt, which is just a label, so it's going to be a piece of static text. Well, not static, you can adjust it later. And I'm going to add that in, and then I'm going to make a button for the rating, which currently just is OK. And when that button is clicked, it's going to call this onSubmit function, and it'll just say, hey, I got to submit. And so it's very basic right now. Let's look at that first and see what it does. So here's this thing, and it's basically has that label in there. This is a test, and I can click OK all I want, and it just prints got to submit there, and it doesn't do anything very exciting. So let's say that we want to take the next step in this thing, and we basically want it to load up the sentences from a file, and show those one at a time. So each time we hit the OK button, it should jump to the next sentence. It should be fairly simple. Okay. So first, we need a file of sentences. Fortunately, I have one of those. These are a bunch of random sentences about a movie I won't shame by telling you which one it is. But anyway, it wasn't a particularly good movie. So I have these individual sentences, one per line. So we want to kind of load this in. And there's a whole bunch of ways, both Python ways and show ways that you can load these in. But I'm going to do this in a show way just to kind of show what that would be. So in this case, I'm going to create a new variable, a new class variable called self.sentences, and I'm going to say that is what we have this command called DLM read, and what DLM read does is basically just reads delimited files by whatever delimiter that you want, and in this case it's just going to be there's only one thing per line, so it's kind of not necessarily that important what delimiter we give it. And I'm going to say And once I do that, so just to, again, because we're working interactively, sometimes it's nice to just, before we actually run with that, we can actually just try that here. Oops, there's no self, there's no object in this content, so I can just do that. And I can look at what sentences, 0, for instance. Oh, oops. Oh, because the sentence has commas in it. Oops. This is tab or something else that it'll ignore. Yeah. So if I look at sentences 0, for instance, now I've got a string like that. So based on what I learned from looking at that interactively, let's change this to tab as well. And here, so let's say, let's also have a counter, which is started at 0. And we'll say that the text, instead of being this is a test, will be self.sentences, self.sentence num. Okay. And of course, right now, the OK button won't change that at all. It'll just stay static. So why don't we have it every time we hit the OK button, it'll at least go to the next sentence. It's incremented by 1, and let's say self dot okay. So let's reload. Oops. So now it shows a sentence, the first sentence, I guess. I hit OK, it shows the second one, shows the third one, fourth one, etc. So that lets me kind of, it shows you an example of what it takes to kind of like, get something, some data. So we could also here, we could do things like we could add more buttons and have it look at, which button's being pressed, and we could save those to a file and so forth. And it all kind of works in the same kind of flow where essentially, you have a little class that has your GUI, and then you have some logic inside it and change it. The point is that, again, with a small amount of code, you can kind of get to something that's fairly functional. The first one? Oh, yeah, sure, I'd be happy to. Yeah. So in that case, so I think that's a good example because it's sort of like the most basic sort of thing that we usually do in an environment like this. We have this data. It happens to be in a file in this case, but there's also cases where this might be in a SQL table that you're doing based on a SQL query and things like that. And now we just want to do some plots of the data and load that up and look at it. So in this case, I'm going to say data. So I'll just use the CSV read, which is analogous to DLM read, but just specializes to commas. Actually, I'll show a nice feature that we have if you get tired of typing, is that I can actually just drag the file name into the console here, and it pops up there, so I don't have to type the whole path. And now I can look at data, and I can kind of see that, okay, well, in each of those rows, if I look at data 0, 0, it's Afghanistan, data 0, 1, it has this population, data 0, 2, it has the size, and I can slice that just like any other kind of data. I can look at these things one at a time. So a basic thing I might want to do, so the simplest possible thing, is that I might want to take the population and plot it against the size and take a look at that. And and let me plot it with blue dots, for the heck of it. So I'm looking at it, and it's like, well, this is kind of hard to see because everything's really clustered into that little spot. I can kind of zoom in, but I can't really see all the data anymore. So let's make this a log-log plot instead. Let's just take a log of both of those axes of data. So now we see a much nicer spread of the data, and it seems kind of we're getting some interesting information here. Of course, right now we don't know what any of those countries are, so it's not particularly interesting. It's just a bunch of dots. So if we want to add the names of the countries, it's a simple matter of saying that the labels is the first column of the data. We'll still use the blue dots. Oops. Put that in the wrong order. Okay, so now we can get a better sense for what some of these guys are. Here's Vatican City with a very small area. I guess the log of area 1 is 0. And then there's the smaller territories of Norway, which apparently has population 1, since it has a log of 0 as well. And these one of the cool things about these labels is they're actually smart. And as I zoom in, they'll actually keep moving around in order to let me see as many different labels as possible, and will rearrange themselves to be able to collide with themselves as little as possible. So at this point, we have this trend over this data, but maybe we'd like to capture, well, what if we were to fit a line to that, or what if we were to try to fit a curve to that? Could we do that, and what might that look like? I'm going to pop this guy over here. So we actually have these commands called polyfit that basically will fit a polynomial of an order that we choose. And in this case, so let's try fitting a polynomial from oops. It's somewhat harrowing to be programming in front of an audience. Okay, oops. What's going on here? Oh, oops. Now I see a problem. Let's see. Oh, right. I need to give it the... So if I hit tab here, it'll tell me what else I need. So the third argument is actually the order of the polynomial. So let's actually fit a second order polynomial, because it looks like, well, I don't know. We could fit a first order too. Second order is more exciting though. So if I look at the coefficients, I have a bias term, and then I have some coefficients because it's a second order polynomial. And so we also have a command polyval. So if I give it a value like 12, for instance, right? Oops. So then it takes these coefficients and then a particular value. So this gets, so 12 would give me 7.8. So okay, that's where it lands. But what we'd like to do is to actually show like a nice curve that kind of demonstrates the fit. So we want a range that goes from, say 0 to 20 here. And then we want to, well, actually, let's say it's a range that goes from 6 to 20. And then we want to plot the polyval of that. So let's say the x in this case is d range from 6 to 20 with a step of 0.1. So if we look at x is a, well, if we look at the values of x, it's what we'd expect. It's these incrementing by 1. And now what we're going to do, so we're going to turn on a hold so we can plot on top of that plot. And we're going to use a little bit of Python fanciness here. So we're going to say we're going to plot x, and then against x, we're going to plot, actually, I don't know if polyval takes vector arguments. No, it doesn't. So what we'll need to do is in fact use that Python fanciness where we say, elt for elt in x. So this is what's in Python. This is called a list comprehension, and basically it creates a new list where each list comes through this iterator generator that happens from inside this expression. So in this case, it's saying go through all of the elements of x, and then for each x evaluate. Oh, oops, it should be polyval coefs comma elt for that. And let's plot this with a green line just for fun. And so here's our, let's maximize this guy again. So there's our second order fit to the data, and we can see how it kind of lands right on top there. And again, this is kind of the typical kind of, playing around with data that you often just end up doing, in the course of doing scientific computing. It's just nice to be able to very flexibly take these different pieces and put them together. I think this example, the one thing this example lacks is that, you could do this in any environment, really. I mean, this is really just, loading up some data and doing some stuff. I think that the leverage really comes for show when you do have some elements that are coming from some kind of .NET library or procedure that you have underlying it. Let's see. I think there's only one that we haven't done yet, which is the looking at the word counts of various files. So let's look a little bit at how that works. So basically, the idea here is that if you want to compute something like the word frequencies that are in a document or something like that, the strategy, is a very common strategy, is that you just create a hash table and then you store the counts of each word as you see it. And if you've seen it before, then you add a count. And if you haven't seen it, then you create a new key for it. So that's all this code is doing here. And let's see. Well, let's not get to that part yet. So this is just for a single file. It's going to come and do this thing. So let's see what this is like in this case. So let's import that file. And let's compute word counts. And I want file name and the counts table. So take one at random here. Yeah, let's reassign it to some output here. Okay, so what's res? So res is this hash table. And if I look at the keys of that hash table, it's all the words that were in that particular abstract. And if I look at the values in that hash table, it's the counts of those words. Well, with one file, it's not particularly exciting. Things get more interesting when we look at a whole bunch of files together. So in this case, the way that works is that we're going to look at all the word counts for some path. And again, this is where we don't have to have extensive stuff inside show to deal with directory things because there's all this stuff in .NET already. And so this is basically taking the directory infrastructure for some path, and it's going through and just going through each file in that directory, and it's computing this, and it's tossing in the same table. And if you remember here in this procedure, there's the optional argument to pop in your own existing table, and if you did have one, then it would just add to that table. So in this case, it's going to use the same table to collect up all the counts for everything that's in that directory. So let's do this again, but in this case, we're going to hand it the whole path. Call compute all word counts, and this will take a second. Okay. So if we look at, so how many keys are there? Well, there's 9,000 keys now, so probably just printing them all out in a list is not so exciting. But what we want to do is to actually sort them by the highest frequency and then look at a bar graph of, say, the most frequent words. Or maybe look at a word, look at the, let's say we want to look at the top 100 words and look at a bar graph of those. How would we do that? Well, Python has a nice command called zip, where let's call it pairs. So what zip does, it lets you take list A, list B, and then it just takes the first element from both of them and puts them into a tuple, takes the second element from both of them and puts them in a tuple, and it puts that into a big list of zipped up items. So in this case, we can do this with res.keys and res.values. And so if we look at pair 0, for instance, that's the word and its count. If we look at pairs 457, that's some word and its count. So now we want to sort these guys. And again, Python makes this nice with its lambda support. And we can just do pairs.sort, and I'm going to give it a lambda a comma b. And if a, so if the count, if the count is, if the count of the first guy is less, then I want to actually do a swap. So now if I look at pair 0, then the first word is of, and it has count 2,119. So now let's look at a bar graph of, say, the first 100 words with the highest count. So we can basically do bar of, and I'm going to use list comprehensions here again to pull out the first chunk of these pairs for the first 100, and then the second chunk of the tuple for this 100 pairs. So I'm going to say take the first 100 and then take the first element of each pair for those. And for the second part, I want the count, not Paris. Oh, because hold is still on, sorry. Okay. So here we go. And as we expect, we have the usual kind of drop off. And now we can zoom in and look at some region here and see, well, what kind of words do we actually get? Those showed up pretty small. So we get the usual kind of suspects, the of, the, and, to, and or, and then we get some kind of like some markup stuff that was in these articles as well. And then we start seeing things that are a little bit more, it's a bit too far, a bit more typical for this community. This is actually from CSCW papers. So you see things about collaborative work, information design, study, which papers support research, more data, IBM. So that's a simple example of how you might do this kind of, text analysis and manipulation to be able to look at stuff. Pop back out to here. And again, I mean, the point with all of these is, of course, these are all very simple exercises, and they're meant to be kind of small and illustrative of the sorts of things that you can do. But the idea is that you should be able to take a small amount of code and typing and be able to leverage some of the libraries that are underneath to be able to do stuff that's useful to you. So I think that at that point, if people have additional questions or thoughts about different kinds of things they might want to do or packages that might be out there, I'd be happy to entertain those.
You mentioned that the show is concurrent, like threads.
Yes.
How can you
So show has, so there's the underlying .NET threads, which you have direct access to. We also have show threads, which are kind of made safe in that, like you said, one of the important things is you want to be failure robust or oblivious to failure. So we catch a lot of the thread exceptions can crash your whole program, and so we do some work to kind of prevent that from happening. So they're somewhat safer threads. There's also some nice types of parallelism for multicore that are built into .NET. So for instance, there's system.parallel.for. So instead of a for loop, you can do parallel.for. And so you can just throw, like if you have a whole bunch of computations to do, you can just throw an iterable at parallel.for, and it can just run that on multicore with very little effort on your part. Go ahead. Mm-hmm. So that's quite straightforward. Essentially, all you have to do is, and you have your choice. Actually, you can either work you can write something that's pure Python and just builds new capabilities or algorithms in pure Python. You can write it in C#, and you can, like you said, you can the existing namespace. None of the namespaces are sealed, so if you want to add, just a show an S namespace, you could add your things to there as well from C#. But there's, well, sorry, were you asking about the mechanics of the package mechanism, or more in terms of like, what would you do to kind of add functionality in terms of?
So the way I was thinking about, I'm not too familiar with
I see. I guess I would say that like in the more so the link extension methods are quite cool, and that's kind of a. I mean, I'd always put that in a different kind of class of things, which are unfortunately, and this is kind of a result of because Python is defined in a very is defined by an external body. It's difficult to slip new syntax into Python, so we actually haven't been able to add link expressions directly to Python, and that's something we're still kind of figuring out if there's a good way to do that. But in terms of if you want to extend existing types, it's easy to do that by subclassing, the traditional kinds of subclassing and things like that. But I think you're getting at the more kind of fancy extension method changes that are now available in link kind of stuff, and I think that'll be coming next. I think that's something we're still figuring out. Okay, cool. Well, thank you, everybody, for coming, and let people go a few minutes early then. And if you have any questions about show or any of this stuff, feel free to contact me later or catch me later during the sessions. Thanks very much.